provides the capability for safe, high-speed, nap-of-the-earth flight. This is the Boeing VTOL Model 360. The technology of tomorrow, available today in the most efficient and durable helicopter yet designed.
Welcome to the Boeing VTOL Company. We're located on the east coast of the United States, just a few minutes by auto from the Philadelphia International Airport. On this easily accessible 300-acre site, we have developed the most modern rotorcraft production and technical facilities in the world. In the tradition of all Boeing products, everything to support our aircraft, from our pilot and maintenance training programs to our product support activities, are and will continue to be the best in the industry. We would like to show you what we're so proud of until you have the opportunity to visit with us in person to see for yourself our products, our people, and our facilities. Boeing VTOL has been an innovator from its very beginnings. Today, this active, state-of-the-art manufacturing complex of nearly 3 million square feet is the evolution of generations of design and manufacturing teamwork, solidly knit together by a dedication to quality. Here are facilities of high-performance production systems organized to convert selected materials into components for major aircraft subassemblies for fixed and rotary wing aircraft. The latest in manufacturing technology, from numerical controlled machining to computerized parts processing and material flow, help our people to achieve the reliability and quality that means Boeing. And continuous quality control at every stage of the manufacturing process makes sure we stay out in front. Boeing helicopters are operating today in civil and military roles on every major continent. We are producing the CH-47 military helicopter, which is now in operation in 16 nations. The CH-47 Chinook is a combat-proven design that incorporates the latest technology for improved performance, ease of maintenance, and greater safety and reliability. The CH-47 can fly up to 80 fighting men to new positions in minutes, or be fitted with litters for medical evacuation. It can carry 10 tons of cargo internally, or up to 14 tons on the triple cargo hooks underneath the aircraft. The CH-47 recovered enough downed aircraft and other equipment from the Falklands to more than pay for itself. Nearly 1,000 CH-47s have been produced to date, and more than 700 of these have been delivered to the U.S. Army. In the mid-1970s, after extensive study, the Army decided that its early model Chinooks could be modernized and standardized at about one-half the cost of replacement and extend the fleet life another 20 years. The modernization effort by Boeing VTOL has resulted in a new, more advanced version of the military Chinook, the CH-47D. An international version of the D model, the Dash 100, is now in production. Japan has selected the Dash 100 for its air and ground self-defense forces, and deliveries begin early in 1986. Boeing is constantly enhancing the capabilities of its CH-47 Chinook, as these aerial refueling demonstrations show. Our commercial Chinook, the Model 234, is currently being used to support offshore oil operations in the North Sea and Alaska. It can carry 44 passengers in airliner comfort, but it can also be easily converted to cargo service and back again, or changed to carry passengers and cargo together. The commercial Chinook represents outstanding potential for the operator in nation-building tasks, such as heavy construction support or construction of electrical power transmission networks. Another important aspect of Boeing Vertol's business activity involves safety, reliability, and maintainability improvements to several hundred CH-46 helicopters in service with the U.S. Navy and Marine Corps. Important as they are, however, we're reaching far beyond these programs with new Rotorcraft developments. We're a major research and development subcontractor to the U.S. Army, developing their requirements for a new light helicopter to replace the Army's aging OH-6, OH-58, and UH-1 fleets with a new scout attack and utility capability. And we're hard at work on a new Tiltrotor aircraft, the V-22 Osprey, for the U.S. Armed Forces. The V-22 combines helicopter versatility with fixed-wing speed for unmatched performance and operational capability. The military implications of the Tiltrotor are obvious, but we at Boeing believe that commercial passenger transportation may one day be a beneficiary of Tiltrotor technology. At Boeing Vertol, the emphasis is on advanced technology and new product development. Approximately 3/4 of our technical personnel are dedicated to research and development. Even in design, almost half of our people are working on new products. Our engineers are using new interactive computer programs and graphic displays to understand the environment of helicopter rotors flying at high speed. Potential flow panel models are being used to predict aerodynamic interactions of rotor wakes on the aircraft fuselage. In propulsion systems, computational fluid dynamics programs are used to optimize engine inlet and particle separator designs by minimizing inlet drag. Aircraft structures are being modeled using finite element analysis for the purposes of sizing structural members to meet the stress and dynamics requirements. To keep abreast of technology and to make our own contributions to it, we have established 4 technology support centers. A subsonic wind tunnel for simulating full-scale flight, and flight test facilities to provide flight test data analysis in real time to ensure timely and accurate decisions. Setting the pace during the early 1980s, Boeing Vertol began the transition to new computer-aided design and manufacturing systems. These computers help to shorten flow time and expand the range of design alternatives. With 3-dimensional computer graphics, new geometric modeling can be created, studied, and refined in a fraction of the time it previously took to perform such work. Our engineering laboratory supports this process with static and dynamic tests of materials, rotors, airframes, and components. Our new $50 million simulator laboratory will enable Boeing engineers to conduct complete system integration research, including full aircraft-in-the-loop testing when our expanded facility is complete. Boeing Vertol was the first American helicopter manufacturer to demonstrate the Advanced Rotorcraft Technology Integration, or ARTI, cockpit in a U.S. Army study to develop and evaluate future cockpit systems. Boeing Vertol's leadership in systems will help tomorrow's military leaders command a potent array of high-performance, computerized flight controls, defensive and offensive systems. The Army's advanced digital operated control system, being developed by Boeing, will shortly be demonstrated on a UH-60 Army aircraft. accumulating millions of man-hours of high-reliability metals manufacturing experience, Boeing Vertol's technology teams have been making a transition to sophisticated composite materials and structures for improved aircraft performance and reliability. The newest expression of that commitment is the Advanced Composite Manufacturing Center. The Composite Center is designed to support two independent paths of manufacture, fed from a common materials distribution center. One route is devoted to panel and component manufacture, and the other to fiberglass rotor blades. All composite materials are inspected upon arrival, coated, and then traced through each stage of production. Automation is used selectively, as in this spreading and cutting of rolls on this innovative Boeing application of a textile industry fabric cutter. Video equipment permits the cutting crew to reposition all part patterns against the material space electronically before it is cut to ensure maximum yield. In another area, automatic 5-axis cutting equipment is used to produce dimensionally accurate cores from stock which may be up to 15 inches thick. Machining the cores virtually eliminates hand shaping and lamination to achieve large sizes. Superior production techniques like this Boeing-designed and developed automated tape layup equipment help us achieve production volume with consistency, ensuring minimum waste. Cured components are trimmed with high-efficiency tools like this water jet. It provides high-speed trimming with increased operator and environment safety. The accumulated composites fabrication expertise of Boeing Vertol is being applied directly to the construction of a technology demonstrator helicopter, the Model 360, a 30,000-pound gross weight tandem rotor helicopter designed with all structural elements and most dynamic components fabricated from composite materials. This means lighter weight, fewer parts, less maintenance time, lower costs, and more payload capability. The simplified design of panel and frame bonded construction means that a single manufacturing jig is possible for the entire production phase. The technological advancements emerging from Boeing Vertol's support centers make possible new dimensions of aircraft performance and reliability in current and future designs. Yes, there is a lot going on at Boeing Vertol, and it is all focused on building a better aircraft to satisfy customer requirements. It is an exciting and challenging time. New talent, new ideas, new facilities. At Boeing Vertol, we're on the leading edge of the future.
Tiltrotors are here. The first fuselage and the first wing and nacelle structures are ready to be mated for the first flight of the first Bell Boeing V-22 tiltrotor aircraft. Tiltrotors are here. Boeing Helicopter Company, and Bell Helicopters Textron, the companies with over 30 years of combined experience in tiltrotor technology, present the revolutionary new Tiltrotor V-22 Osprey. The V-22 is the world's most versatile multi-mission airplane. With the Tiltrotor's unique capability for taking off and landing vertically, and transitioning to turboprop airplane flight while aloft, the V-22 offers a combination of speed, range, and flexibility never before available. In its airplane mode of flight, its turboprop efficiency allows it to fly ferry routes of more than 2,000 miles without refueling. A conventional helicopter with comparable lift capability takes 5 days and aerial refueling to reach Europe from the United States. The V-22 will require no tanker support and can arrive the next day. Through its advanced avionics, it will be able to perform long-distance, low-level flight under cover of darkness with little likelihood of being detected. Terrain following and terrain avoidance equipment will enable it to maintain high cruise speeds throughout the mission, despite low altitudes, bad weather, and hostile environments. The first flight in June will introduce a totally new aircraft, incorporating new ideas, new materials, and new manufacturing techniques. It is the first production aircraft with an airframe to be fabricated almost entirely of composite materials, chiefly graphite epoxy solid laminate structures. Composite structures weigh about 25% less than their metal counterparts, offer good resistance to corrosion, good ballistics tolerance, and ease of repair. Also, the composite airframe and buoyant fuel sponsons give the V-22 flotation characteristics sufficient to eliminate separate emergency flotation systems. The V-22 is designed to be easily maintained. Large cowling allows quick access to nacelled components for inspection and maintenance. Special panels provide built-in work platforms for safety and convenience. These platforms are at the correct height to allow work to be performed on any major component with a minimum of effort. The wing of the V-22 can be rotated parallel to the fuselage to create a compact rectangle for storage in small hangars or aboard ship. This unique solution places the V-22's wing, rotors, and engines directly above its fuselage. These characteristics particularly enhance the ability of the U.S. Navy and U.S. Marine Corps to maintain, operate, and repair the V-22 while underway at sea. V-22 avionics is fully integrated with all other aircraft subsystems through 2 onboard data processors. Computer-driven displays will provide the pilot with engine, navigation, and subsystem information. Pilots will be able to access all aircraft subsystems and instrument readouts on 4 multifunctional color display monitors located directly in front of them. More V-22 Ospreys are coming together at our factory. Since these views were made, a second fuselage has been removed from the jigs for the addition of weighting elements, and a 30-foot test specimen is being statically tested. Full-scale developments began in mid-1985 and will continue until operational flight testing is completed in late 1991. During this phase, 6 flight test aircraft will be built, with 3 additional aircraft being constructed for fatigue testing, static testing, and full system ground testing. Over 4,000 hours of development and operational flight testing is scheduled. The V-22 Osprey will satisfy the operational requirements for medium vertical lift of all 4 U.S. Armed Services through the 1990s. The U.S. Marine Corps will utilize the V-22 to carry 24 combat-equipped troops from ship to shore in a combat assault role. Marines will also use the V-22 to carry external loads of up to 10,000 pounds. The U.S. Navy will initially use the V-22 for combat search and rescue missions, special warfare, and fleet logistics support. They also plan on a variant to be used for anti-submarine warfare. The U.S. Air Force will exploit the long-range capabilities of the V-22 for their special operations. Its introduction will provide a vertical takeoff and landing aircraft with an exfiltration range compatible with the current infiltration range of the MC-130 Combat Talon aircraft. The U.S. Army will employ the V-22 in such multi-mission roles as combat assault, assault support, medevac, and core area operations. Tiltrotors are here. Project pilots from both Bell and Boeing have engaged in extensive simulator training programs in preparation of this arrival. They are ready. And the Osprey is ready.
The CH-47D Chinook brings new capability and versatility to helicopter support operations anywhere in the world. Developed from lessons learned during more than 2 million flight hours and extensive combat experience, the new CH-47D incorporates state-of-the-art aircraft systems into a proven airframe. This has created a next-generation transport aircraft. Modern, reliable, and mission-effective well into the 21st century. The standard adverse weather cockpit, coupled with night vision goggle compatibility, means a true around-the-clock support capability and expanded mission effectiveness. The CH-47D can carry payloads in excess of its own weight, lifting loads greater than 12 tons. This gives Army units the capability to rapidly deploy large tonnages of weapons, supplies, and containerized support equipment. Large, non-divisible loads can be moved by the Chinook in a single lift over impassable terrain. This means that equipment arrives ready for immediate use at the destination. The triple hook cargo system adds outstanding flexibility to external load handling. By utilizing all 3 hooks, the CH-47D is able to deliver supplies to 3 separate units in a single sortie. Tandem rigging, utilizing the forward and aft hooks, permits increased load stability in flight, with transport speeds in excess of 120 knots. The 1,500 cubic foot volume cabin is accessible over a straight-in rear ramp for internal loading. The tandem rotor design provides clearance to load the aircraft directly from truck beds, converts all delivered power into lift for top performance, and enables precise hover, takeoff, and landing without regard to wind direction. The Chinook does not require any pontoons or special refitting to perform water landings in rivers, lakes, or streams, or in the open sea. The Chinook is deployable to support operations anywhere in the world. The optional extended range version provides the necessary fuel capacity to complete deep penetration, special operations, extended border patrol, and SAR operations over a range of more than 1,100 kilometers, or up to 6 hours of continuous flight. The availability of the Chinook for the performance of its multiple missions is high, because it was designed to live in the field. It can be readily maintained even in very remote areas without the need for special support equipment. Even the composite rotor blades can be repaired while they are on the aircraft. All this means that the Chinook stays available where and when it's needed. Effective combat operations rely heavily on close and continuous integration of helicopters into ground tactical plans. With the capability and mobility provided by the CH-47D Chinook, the ground commander has the ability to bring a striking force along with supporting equipment and supplies into action virtually anywhere within the battle area, concentrating it where needed most to meet and defeat any enemy threat. For example, moving reinforcements over significant distances from 125 to 150 kilometers over surface routes can take several hours at highway convoy speeds. The same move can take more than a day if the vehicles are forced to travel cross-country. A company of 16 Chinooks can move a full battalion of troops and their supporting weapons that same distance in a single lift, taking less than 1 hour. This difference in time could mean the difference between success or failure of the mission. The high-volume capability of the Chinook makes it a viable alternative means of transport for large-scale supply point operations. In a single lift, 3 Chinooks can deliver 36 tons of cargo. 6 Chinooks can deliver 72 tons of vital supplies. And a company of 16 Chinooks can deliver as much as 192 tons in just one flight. For priority movement, or as a supplement to overextended or temporarily blocked surface transportation systems, a single Chinook company can readily maintain a brigade-level supply point until surface routes can be reestablished. The Chinook transport capability offers the most effective use of military assets with the least amount of vulnerability to enemy attack. In support of divisional artillery, a single Chinook can move 2 4-man gun crews, 2 105mm towed howitzers and their ammunition, or 1 8-man gun crew with its 155mm towed howitzer and ammunition, and transport them at 120 knots to any desired location. situation develops, Chinooks can transport anti-armor teams and their support equipment from any site and deliver them to a new operational location with sufficient supplies to keep them effective in a blocking action until the arrival of reserves or other defense teams. In the initial phase of a developing battle situation, the legs of supply and resupply are long. The lost time spent traveling to and from a base to refuel and rearm can be critical for the effectiveness of combat power. The Chinook increases combat effectiveness by establishing forward area refueling and rearming points and keeping these points supplied to continue forward operations. Changing priorities on the battlefield increase the importance of the support role of the Chinook. When the advance is halted or the battle is stabilized along a relatively fixed line and other support equipment is phased into the operation, the Chinooks can be directed to other areas. The next priority may be supporting engineers in the restoration of key transportation arteries. Road building equipment is airlifted with little or no disassembly for delivery to waiting engineers who move it to work as fast as it arrives. Superior combat power, applied at a decisive time and place, decides the outcome of a battle. The necessary tactical mobility to place weapons and troops within effective range of critical targets is a vital ingredient to combat power. The ability to move men, machines, and firepower quickly and effectively at any time, in any climate and terrain, makes the CH-47D Chinook the incomparable prime mover.